Hi, and thanks for joining us today. We're going to have a conversation about Brocade's new Gen 8 Fibre Channel platform, and I've got my friend Marcus along with me today to have this conversation. So, Marcus, among the conversations that we wanted to have a little bit today is pretty heavily security-based, security-focused. The nightmare that is security in IT today, and some of the effects that's having. So things like I'm seeing people bring platforms back in from the cloud because they want better control over it. So not just the cost aspect of it, but then also just the sheer volume of bad actors in the market, and the volume of bots that are loose in the world, and the overall attack surface for IT these days. So tell me a little bit about how we're doing in Gen 8 to look at some of these things.
Yeah, that's true, AJ. I mean, security is front and center. Every time I meet with a customer, that's probably number one on the list, what they want to talk about. Of course, they want to deliver the services in the data center to the applications, but it always has to be secure.
Yeah.
And so really what we did, and it goes back some, even when we developed the Gen 7 product line, we really put a very clear guideline that we wanted to make sure that we could deliver the most secure network in the data center. And we've really used that as our guiding line also as we developed Gen 8.
Mm-hmm.
And so you will see that really come to fruition through a couple of different things. You'll see with how we harden the operating system even more. We now use something we call principle of least privilege. This is the architecture within FOSS where every module, every command has basically mandatory access control to the components they need in the operating system in order to execute.
So you don't just give me the keys to everything.
Exactly.
You're being a little more restrictive.
What it really means is that if there is a vulnerability in a software module within FOSS, then you cannot from there basically jump to another module and then exploit that because you would not have access.
So it's a security version of sort of the Sarbanes-Oxley financial constraints, right? You don't want one person having privilege across everything.
Exactly. And if you're familiar with how SE Linux architectures are, it's basically that same architecture we have adopted.
Right.
So that's one point to just secure the operating system more. In addition to that, we have adopted the guidelines from NSA around CNSA 2.0, which means that we've adopted quantum secure or quantum resistant algorithms.
Yeah.
And as you and I, we talked about the other day, the guideline from NSA is that by 2030, you should be compliant.
Yeah.
But as we also know, if you don't start today, you're not going to be there by 2030.
Yeah, I think it's a pretty true thing that most customers can't refresh more than about 15 to 20% of their footprint within a given year, right? And so you have to start the progression now. The hackers aren't going to give you any more space. They're not going to back off and go, oh, you're having a hard time getting your infrastructure up to par. We'll give you some space. That's not going to happen, right? They're out there hammering at anything. I know you've told me a number of times that you could stand up a server in the DMZ and then push that DNS update out, and you're going to see thousands of hits against that machine within 24 hours, right? So everybody is a target, right? There's no safe corner of the internet anymore, right?
Exactly, and I mean we can see it. There was a funny thing the other day. I was just looking at how many ransomware attacks are there, because obviously those are very scary. And if we look at publicly announced ransomware attack, in March this year was the first time that there was more than 100 publicly reported ransomware attacks in a month. And so that means how many are there that we don't know about? It's usually healthcare and government organizations that are mandated to basically announce or disclose. But it's up, I think it was 80% year over year.
Oh yeah.
In March. So.
And that's the people who are willing to tell you that it happened, as opposed to the folks that do that. Well, we don't need to say anything because we paid the rent. Like the blackmailers aren't still there, right? So, I think it's a good reminder.
Yeah, and there's so much focus on AI today, right? AI can be a great helper and a tool for us to do a lot of things. but it's also a tool for someone who has a malicious intent.
Yeah.
And you and I, we've talked about before how you can basically take the list of publicized CVEs and then spit it into your AI tool of choice and ask it to generate code that can exploit these vulnerabilities. And
the University of Urbana, Champaign, Illinois, did that study, and they said 80% of the CVEs that they fed into the AI, it was able to generate the exploits for it. So that's a pretty scary number, because it means somebody with no software skills like myself can generate exploit code, right? Just by asking, and that's a significant challenge, and in particular because now the hackers have moved from encrypting everything to intermittently encrypting 1% of the data set, which still means you can't recover from it, right? So it still breaks everything. It's still an effective blackmail, but now it's much, much harder to detect, right?
Yeah, exactly. And I think what we really did when we developed Gen 8 was we decided, okay, we're going to follow the CNSA guideline, which basically means make sure you use encryption algorithms that are considered quantum resistant,
Yep.
meaning you can't break them with a quantum computer. That's number one. But at the same time, we decided, okay, we're really going to draw a line in the sand with our Gen 8 product line and say, okay, all non-secure protocols, we're not even going to allow them on the platform.
Yep.
All weak hashes or weak algorithms, we are deprecating.
Yep.
And then in a later release, we're going to say, okay, now you can no longer use them anymore. So we are obviously creating a soft transition so you can go in and adopt Gen 8 in your data center today, and then you can transition into this highly secure infrastructure.
Which is the place everybody needs to be, and we're just making that entry into it easier.
Exactly, and going back to the timeline for this, we expect that the next 5 years is really where customers are going to move towards using quantum resistant algorithms, and at the same time, basically remove all non-secure protocols, all weak ciphers, etc. along the way.
Yeah, and I think we could make the argument there's never been a successful hack of a Fibre Channel SAN, but that's not really a security practice that you can say security through obscurity is a good plan, right? So we obviously are moving customers into that base because we need to. So with that said, maybe you could talk to us a little bit about what this means and what this new Gen 8 technology is going to encompass. How are we doing some of this? Like what are some of the pieces for this? So you've talked about moving us to different encryption algorithms. You've talked about the principle of least privilege and so on. Maybe walk us through a little bit. And I'm assuming some of the customers are looking at this and maybe being a little bit wondering, hey, is this gonna cause me a challenge to begin to take this in and consume this? And I think you guys have been pretty focused on making sure that it's pretty straightforward to make use of this, right?
Yeah, I think the security part aside, really what our goal there has been, again, to enable a very smooth transition from your existing infrastructure to the Gen 8 infrastructure.
Yeah.
And so everything is fully compatible, but we sort of lead you on the path to stop using non-secure protocols, stop using weak ciphers, and so on and so forth. So that's the whole security side of it. But if we look at more at the feature functionality side, obviously there our focus is always to make sure we deliver what the end user or the customer needs to meet the storage SLAs of the infrastructure. Yeah. And so a couple of things we've done. Number one, we include all features in Gen 8. So that means you don't have to worry about it. Do you have this feature on this switch or that switch? All features are included in the platform, number one. Number two, we had this very good foundation with the Gen 7 platform around the autonomous SAN, and we've really taken that and developed the next level of the autonomous SAN. Okay.
So one of the things that comes up in this conversation, because you were just talking about, the length of time, or we were talking about the length of time it takes customers to get through. And, the reality of the situation is everybody's got a mix of technologies on the floor, right? You're going to have, next year you're going to buy a next generation of server that's going to be faster and have more memory and have more cores, or you're going to buy more storage that's got a faster interface, or maybe better anomaly detection, or maybe better deduplication and compression algorithms and so on, right? So you're going to have these mixes of technology, and we joke about this a lot, but it's a little like you and I being on the highway at the same time, right? You are a much more performant driver than I am, right? I'm the grandfather in the family car kind of thing, right? So, how do people deal with that, right? Because the most common cause of congestion in any network, regardless of whether it's Fibre Channel, Ethernet, or InfiniBand, is this mismatch of performance between devices, and they're all still critical. I had a customer talking to me just on Tuesday this week about not being able to sunset some applications that he's got, right? And the issue is those are still mission critical to somebody. They still have to perform. So you want them to be in there. You want to give them all the same feature and security and everything else that we give to things, but you don't want them. You don't want AJ to be disrupting Marcus's commute to work.
No, I think, as you said, right, it's important we all get there. Right?
Yeah.
It doesn't matter if it's you or me driving to work. We all need to
I
get
like
there.
to think so, yeah.
We're all
yeah.
equally important in that way. But it is true that if we look at the different generations of devices in the network, they just perform differently.
Yeah.
And so we see this across practically all our customers. You will have an older application server talking to a newer storage array, and vice versa. And what it creates is this mismatch. And the easy analogy is always, if we look at the multi-lane highway, right? We have some cars drive faster than other cars, but if we can, and that's really what we did in Gen 7, right, with Traffic Optimizer, if we can make sure that cars that have the same speed, basically, and some, you could say length, if we take in like the protocol piece of it, then you put them in the same lanes. And so everybody goes as fast as they can. Yeah. That's really what we want to try to solve to. Yeah. Now what we've done with Gen 8 is we've taken this to the next level. We have something we call adaptive traffic optimizer, which means that in Gen 7 we had to pre-provision the lanes and say, this lane is for this type of traffic, this lane is for that type of traffic. And then they were statically allocated. And if there was no traffic of type 1, for example, that lane would just sit there empty and nobody would use it. The difference here with Adaptive Traffic Optimizer is that Traffic Optimizer basically auto-learns what kinds of traffic are in the network and then provisions lanes accordingly. So if there is, let's say, multiple type 1 types of traffic, it will basically provision multiple lanes of that and no lanes of type 3 traffic if there is no type 3 traffic, for example. So you get a much more efficient use of the resources and thereby a much more efficient storage network.
Yeah. So when you said you used the phrase pre-provision, but for a lot of people when they hear you say that, they think, oh, Marcus is telling me that I've got like 30 to 50 commands on every single type of traffic that I want to have that's going to do this, but that's not the reality, right? That's not how we do it.
In Gen 7, really what it was, you picked one policy that fit the types of traffic you had, and it would define, okay, we need these lanes, and it was basically a single command. Now in Gen 8, there is no need for that because the Gen 8 platform automatically learns. The ASIC is so advanced, it can automatically learn, okay, I see these types of traffic, and then adjust it accordingly.
Yeah. Well, and I think one of the things to just remind folks about is that Fibre Channel is different than Ethernet in the respect that we have the fabric login, the name service registration, process login when devices start talking to each other. So we know all of the characteristics of every element attached to the fabric, right? We know who they're talking to, and we even know the path they're taking across the fabric, right?
Correct.
So that gives your autonomy a better footprint to work from, right? To decide what to do with things. So, and that's great. And you look at the telemetry that we do, and we do a level of telemetry that the Ultra Ethernet Consortium is just beginning to dream about, right? And that's all grand too. But how do we not just drown people in metadata about their data, Marcus? Like, what are we doing about that?
Yeah. So we've done a lot of things, right, with enablement around maps, etc. But really what we've done here on the Gen 8 platform is, again, we've built on all the experience we've done with the Gen 7 platform. We've applied what we call SAN AI technology. what that...
So you're actually taking an automated, an artificial intelligence kind of view, an AI kind of view, for a SAN AI in a running environment.
Correct.
Okay.
Basically what we do is we enable the end user through a few commands, completely understand, okay, are there any performance issues in my fabric? And really the problem or the challenge we're trying to address here is when an application owner calls the storage team or puts in a ticket and says, hey, my application is not performing the way I expect it to do,
Yeah.
and I think it's the storage that's the problem.
Yeah.
Now the storage team has to either prove innocence or find out what is the root cause and how do we solve to it.
Yeah.
And the storage network obviously has thousands of servers and maybe tens or hundreds of thousands of VMs.
Yep.
And where do they start looking? And so that's really where we looked at, okay, how do we do this in a much smarter way? Because again, our most experienced users could do this,
Yeah.
right? What they would do was, they would pull telemetry data from all the switches, they would cross-correlate it,
Yeah.
and then understand, okay, what is the problem? Or, is there a problem in the storage network that relates to the application performance? But this would take them time, and number one, and number two,
yeah.
a lot of expertise,
Yeah.
right? And so we really took a step back holistically and said, okay, how can we solve this so the end user can do this without necessarily having much experience, and then of course cut away all the time it takes to do this.
And so I think one of the key elements there for me is that customers look at this, because pretty generally when I'm talking to data center customers, the storage team is always the first place the finger gets pointed. Whenever if there's a performance issue, it's got to be the storage, right? That's I know, but I mean that tends to be like the default, right? It's always the victim. And so for a lot of our customer base, this tool set, right, and in particular the things you're doing with the SAN Fabric Intelligence, and the sort of AI that the SAN AI that you're building in, is shortest mean time to innocence for the customer. Right?
You could definitely look at it like that. I think really what's important here is that what SAN Fabric Intelligence provides you is, through a single command, a full summary of what happens in your network. Yep. And then from there, you can start going closer and closer to understanding exactly what is the reason, who is impacted, and why they're impacted.
Yeah.
And the way it works is, as I said, it's really, you start with a single command that says, okay, give me a summary of what my fabric looks like. And the summary will tell you there are this many, there are this many switches, there are this many ports, there are this many servers, this many storage, VMs, etc. And then from there you can say, okay, show me just all the VMs, where they are, or show me all the VMs that have any kind of performance problems.
Yep.
And then you will see, okay, these are the ones that have any kind of performance problems, and then from there you can pick each, we call them congestion events or performance events, and you can say, okay, show me the details on this congestion event, and it'll tell you what is the root cause for the event. So is it an oversubscription issue? Is it a different issue? And then who was impacted by it? Last time this event happened, how long was the duration?
Yep.
And also what was the latency impact from this? And on top of that, how many times has this reoccurred over the last day, the last week, whatever? So really what we're doing here is we're taking what before took the very experienced storage admin, maybe an hour, maybe longer, and tons of commands across multiple switches to get to. Now he can get there in like a minute or two.
And I think one of the key elements for people to remember about this is that when we talk about the length of time it takes to answer that phone call, right, and the reason why integration to the virtual machine is so critical is because that's where the application is. And application owners and business line owners are not particularly patient people, right? And so when they think there's a performance problem for their business line or for their application, they want an answer now, thank you, right? And so if it took you an hour and a half to come back, the person on the other end of the phone is wondering, hey, did this guy take a lunch break? What's going on? So I think this reduction in time to get to that result, I think is going to be massive for people.
Yeah, and we should remember that application owners are not just impatient people, right? I mean, they are basically responsible for an application
Right.
that often drives a lot of revenue for the organization, or is just critical for the organization. Remember, it is mission and business critical applications running on the network.
Yeah, well, in particular for Fibre Channel, it tends to be
Yeah.
the business critical, mission critical. And to your point, and it's a really good point. It's also the customer experience, right, and the reputation of the application and the business line that are on the line with that as well. So fair point.
Yeah, and I think one additional thing of, a complexity level that we sometimes forget when we talk about an application. An application is not like when you and I were young, that runs on a single server, right? An application is, maybe 10, 20, 30, 50 VMs that work together at different layers of the application.
And potentially running
architecture.
across multiple platforms, right?
Yes.
So not to your point, not 3 VMs on one piece of hardware. It could be pretty diverse, right? So knowing the context of that environment is critical as well, is what you're telling me.
Yeah, and really being able to see it all at the same time, that is what we bring you with Sand Fabric.
And that's that
Intelligence.
holistic image you were talking about in terms of solving to that problem.
Exactly.
That's pretty
Yep.
cool.
Yep.
So, one of the things that you and I have, because we've been at this for a couple of years, right? So one of the things that you and I have talked about with this before is every time we come out with a new iteration of technology, there's always the discussion of the speed step, right, and the performance, right? And performance has a lot of characteristics to it. It's not solely just the signal rate. There's a lot to do with the integrity and quality of the environment as well, right? And so, I joke with customers to a degree that, we've been talking about this for a long time, and the reason that you're still running Fibre Channel, right, is that it does things for you that other topologies and other technologies can't do, right? It's a flat statement for some customers. You actually use the view that if you could have moved off of it, you would have by now, right? Because you've been looking at technology for 2 decades, and we consistently, year after year, provide that level of integrity, performance, security that just drives people to put, if you look at the Global 2000, 95% plus using Fibre Channel for their mission critical, business critical material. And one of the things that I'm pretty happy about with the Gen 8 is that the forward error correction algorithms and so on that are in this technology give us a data integrity for signaling that's 3 orders of magnitude better than 100 gig Ethernet, right? And when we start looking at this, I also want to remind people that, and you and I have talked about this before, it's not just the cross-sectional area of the pipe, right?
No.
There's an overhead to the protocol stacks and the way things happen. And so when we talk about performance, you've got a lot of facets and parameters that go into providing that kind of environment for us. So how does that work exactly for us now?
Yeah, so obviously with Gen 8, we released 128 gig Fibre Channel support. But not only that, as we talked about the signal integrity, we are also applying what's called a dual FEC, so dual forward error correction. And so this is absolutely critical to make sure you have full signal integrity, and you can run at the same 100 cable meters as you can with 64 gig.
Yep.
So there are no issues there, and I think that's just important to remember that we come with basically double the speed now with Gen 8, and you can still use the same cabling infrastructure that you had before. There's full backwards compatibility, etc. So it all plays into all the wonderful, I would say, or required, however you put it, properties of Fibre Channel, where it's always on, fully redundant, and so on, resilient, performing.
Yeah, dual redundant, hardware isolated, right? Low latency, lossless, right? Deterministic delivery, right? Because one of the challenges with some other protocols is, sure, the data will get there eventually, but you can't say when. You don't know when a transfer will finish. And you look at some of this stuff, and in particular some of the topologies for this, right? You hear the Ultra Ethernet people talk about problems with incast, so many initiators talking to single targets, because TCP wasn't written for that, right? It was written as a different style of protocol for a different use case. Not that it doesn't have a use case for certain portions of the storage market, right? But again, the Fibre Channel side is that nonstop mission critical environment that people use for stuff that absolutely has to stay up all the time. It's the place you put the data and the applications you actually care about, and everything else is sort of okay enough, right? So, but so it's easy for us to talk about that as a protocol change, but maybe you can also give us a bit of an outline around what products are we actually launching, right? Where are we, and what's out there for the customer to be excited about today?
Yeah. So obviously, I mentioned a couple of times the new operating system is called FOS 10. That's obviously the Fabric OS that runs on all the switches.
Yeah.
And with that, there's also the management platform, SANAP. It's 3.0 in this release, or supporting the Gen 8 products. And then we have a chassis. We actually have two chassis, right? We have one with 8 port blades and one with 4 port blades. And then we have an enterprise switch.
Excellent.
And we can go into a little bit more detail on what those platforms actually look like.
Okay, so when we talk about the chassis platforms, and you say an 8 port and a 4, so you're actually talking about eight port blade slots and 4 port blade slots, right? So pretty broad range of fit for varying customers, because not every customer has a one size fits all sort of environment. But how is this architected, and is it going to give us the same kind of performance characteristics that we've come to expect from Fibre Channel over the years, over the decades that we've all been doing this?
Yeah, certainly. I mean, obviously, we build on the same capabilities we had on Gen 7. It is a new hardware platform. Okay, so you will see it looks a little bit different. The dimensions are almost the same. It's a little bit deeper in the rack, but it's the same RU. And as you mentioned, it delivers basically either 8 port blade slots or 4 port blade slots. And we release with a 48 port blade, so you can have 8 times 48 ports, or just over 380 ports in the large director, and then in the small director 190 something odd ports.
192. Yeah. So pretty much a match to the Gen 7 platforms that we had here. But one of the things that you've also included in this is the inter-chassis links, right? And the scale on those has changed somewhat, right? I was a little surprised to see we've actually got per chassis on the 8 slot up to 128 ports of inter-chassis links, right? So maybe a word or two about how that plays for customers in terms of the efficiency for server and storage connectivity and so on, when you're building out these fabrics that just can't fail.
Yeah, I mean, one of the great things we've had in the architecture across our director platforms is this inter-chassis link capability that enables you to interconnect the chassis without using port blade connectivity.
Yeah.
And so the ICLs, the inter-chassis links, they connect directly to our routing blades or core blades in the back of the chassis. And so what that means is you get the lowest possible latency across chassis, and it enables you to build out these very large fabric infrastructures, basically with these inter-chassis links.
So one more point that I want to get you to spend a little time on is one of the things you and I both run into with a lot of customers is there's a mix of storage technologies in the world, right? And one of the challenges for a lot of our SAN admins is that frequently they're put in charge of, say, an iSCSI environment or an NFS style environment and so on. And it's harder for them, right? Because they don't own the network that's connecting those devices, right? But they still get poked at and yelled at when the performance of the we'll use iSCSI as an example. So the performance of the iSCSI platform is seen by the application business line guy as, hey, that's a problem, Marcus. What are you doing about it, right? And Marcus goes and looks at the iSCSI array, and there's no problem with that. And then he's got to do that hard thing of going to his colleague and asking, is there a problem in the network? To which the answer seems invariably to be, there's no problem in the network, right? So, which is somehow weird, but so what are we doing to help that?
Well, so it's no secret that running critical applications on an IP infrastructure has been very, very hard.
Yep.
I mean, I have done it in my past before I came to Brocade, and I've talked to many customers who've tried it. It's not easy to do. It's very hard to meet deterministic SLAs on an IP storage
Particularly at
infrastructure.
scale.
Yeah, it's particularly at scale. If it's
Yeah.
single switch in and out, no problem. But if you start having a network of a certain scale,
A true
it gets
spine
harder
leaf
and harder.
architecture or
Yeah,
super
it-
spine
it-
spine leaf architecture, totally different world.
Because there are many different reasons,
Yeah.
right? Number one, your storage traffic is competing with other traffic.
Yeah.
Number two, we talked about the incast challenges
Yeah.
that the ultra Ethernet guys are looking at.
Yeah.
They're rarely the same traffic types for other applications in the IP network, and it creates these hotspots
Yeah.
that you have with them, with incasts.
One of the fun things that keeps coming around is we keep relearning the same things over time, right? And so, most people who've got any kind of history in IT are aware that we took steps to keep the backup traffic away from the application traffic for years and years, right? And then, when you start doing these, I'm going to collapse everything to a single Ethernet network because that's going to be the lowest cost implementation. But, don't worry, Marcus, I'll isolate the traffic with a storage VLAN, right? And then I look at them and I go, okay, well, so you remember why backups across the application network are a bad thing, right? And the impact it has, and it turns out that restore is just a reverse backup, right? And those happen when applications go down, and it's not like, I can set up a window and go do this. It's like, no, you got to be back up and running really quickly. So what are we doing to help the overall IP traffic issue for storage?
Yeah, so for many years, actually for many generations, our ASICs have had the capability of transporting both Fibre Channel and IP. And so back with a release a couple of years ago on the Gen 7 platform, we included what we call USF, Unified Storage Fabric.
Okay.
What that enables you to do is to carve out a number of ports on your director and say, I want to use this for IP storage. And what you create is basically a logical IP storage fabric, and it can be across multiple directors.
Okay.
And now you get basically a dedicated network for IP storage that you can run in parallel with your Fibre Channel on the same network with the same capabilities around maps and monitoring and management capabilities for the storage admin. But more importantly, you now have separated the traffic out from competing with other traffic in the application network.
So it sounds like much better telemetry and management visibility than in traditional Ethernet networks. But aren't you then just bringing all the security issues of Ethernet into the SAN and compromising the SAN?
Not really, because see, the good thing is that we know this is going to be storage traffic, right? Or at least we sort of set that prerequisite and say, okay, Unified Storage Fabric is really designed to deliver to storage traffic. What that means is we can be very stringent on what type of protocols we allow, what type of traffic we allow on the network. So if it's something that doesn't have any place from a storage networking perspective, we don't allow it. So we don't allow any bump traffic, for example. No broadcast, no unknown unicast, no multicast. So we make it a lot harder to basically, you cannot sniff on that network like you can on an Ethernet network.
Okay.
So we've done things like that where we've really taken a lot of the good traits of the Fibre Channel network and then applied them to the IP storage network.
Do the USF platforms, the IP platforms on USF, do they have visibility to the Fibre Channel traffic?
They do not. No.
So they can't change anything in the Fibre Channel side
Correct.
of it.
They run completely separate in parallel on the same physical infrastructure, but there's no logical connection between the two.
So there's no peering between a fabric that's IP across one of our directors
No.
and the Fibre Channel side.
No.
Okay, so total isolation.
Total isolation, yes.
Great. So in addition to the directors, though, we've added in an enterprise switch, right? So maybe you can give us a little bit of an overview. You know, with a lot of products out in the world, every time you've got a different size platform and whatnot, it's a different version of code that goes onto it, and you know all sorts of customized pieces for this. You know, and you know what features are there. So maybe you can walk us through. Is ours different or is ours the same?
Well, so again, this is something we've done for generations of products. We have full parity on the feature set with the enterprise switch. So there is full feature parity between the enterprise switch and the chassis. We use the same ASIC in the products. And as I mentioned earlier, all features are enabled per default. Okay,
Yeah.
so there are no features that you have to enable later on. They're all there. The scale goes from, you know, the initial footprint is 24 ports enabled, and then you can basically scale it up to 56 ports total.
Yeah.
Of course, all running 128 gig line rate, no oversubscription in the platform.
But you're just turning on more ports. All the feature functionality is the same across everything. It's already
All
there.
is there.
No installations, nothing
not
hard
at
to
all.
do.
And of course, everything, for us is the same. There is no difference, really. Yeah.
Great. So, you know, if we want to think about this in terms of, you know, the overall takeaway we want customers to have for this Gen 8 launch, right? Our Brocade Gen 8 Fibre Channel platforms have a set of characteristics, to your point, that we have for decades built on, right? So these are always continuing enhancements and things that, frankly, we've learned from customers. So what do the customers need? What are we seeing? What things are driving them as their workloads change, right? Because it's not like their world has stayed steady state at all either. No. So, you know, maybe you can give us just a brief summary of what are the things you think customers are likely to care about most with the Brocade Gen 8 Fibre Channel platforms?
Well, as we all know, security is always front and center. So I think that is probably number one.
Yeah.
Number two is, at least every time I've shown it to customers, is this SAN AI technology that we have embedded. It really makes a huge difference that the SAN admin can basically, with one or two commands, completely understand what's going on, and then from there dive in and say, okay, I can see it's this type of problem, this is the reason, these are the applications that are impacted.
But in this instance, I think one of the things that strikes me as different about what you guys have implemented is that for Brocade, you're talking to runtime engines in the switch and the Fabric OS. This isn't hey, let's do a whole bunch of capture, send everything off someplace, you know, to be munched on for an hour or 2 hours or 3 hours or something, and come back. So there's a portion of this that's real-time control, things that you're fixing on the fly, right? You know, because in my view, at least talking to customers, humans can't really be fast enough anymore. If we're waiting for AJ to get a notification that there's a problem, then wait for AJ to go look and see what the data around the problem is, and then AJ to think about what the solution to that problem is, that's a problem, right? You know, by itself, that's a problem. So, but you guys don't do that.
No, I think that's really what we did with the autonomous SAN, right? Along the way was, okay, identify what are the issues in the fabric, and then mitigate whenever we could, but always, of course, alert on it. I think what we're doing here with SAN Fabric Intelligence is really taking it to the next step, that we're not just sending you an alert on what's going on, we also enable you to basically, with the touch of one or two commands, understand exactly who's impacted and what was the root cause.
Yeah, because sometimes, right, the device that might be seen as being the bully in the environment may be the more critical application, and that's not the application you're going to move, right? Or you know, you're going to take the competing traffic away from it. Yeah, so that seems like a really good benefit. So we want to thank you very much for joining us on this discussion. There's a lot more detail to know about Brocade's Gen 8 Fibre Channel platforms, about the automated SAN AI that's involved in it, and all the feature sets. So feel free to go to the Broadcom Learning Portal and have a look at more detail on these. Marcus, thanks again so much for
Thanks a
having
lot,
this
AJ.
conversation with us, and thank you again, folks.